Good morning to all. I am Subramaniam from Automobile Engineering in SNS College of Technology. In this session, we are going to see about the transmission system. In the transmission system, we are going to see about the manufacturing of the composite friction lining. The friction lining mostly depends on the brake pads. Here we see about the composite the friction linings, how the materials to be selected for it, and of formulations, and what are the mixturing for the lining purpose, for the manufacturing lining purpose, and what is the pre-forming. Next comes the molding and curing. Finally comes the finishing, and we see the quality control also. So just we started from the manufacture of the composite friction lining, which involves several critical steps that combine materials to create a components used in the braking system, clutches, and other applications requiring friction management. Composite friction linings are essential in automotive, aerospace, and industry machinery due to their ability to provide stable friction performance, wear resistance, and heat dissipation. All three are important here. It must be stable in the stable friction performance itself, and also it must have long durability, that is wear resistant, and also it has to dissipate the heat. Since the heat is more absorbed, the material may be wear and tear itself. So first we go for the material selection itself. In the material selection, the process begins with the selection of raw materials, typically including fibers such as armament, glass, or carbon, and fillers, binders, and friction modifiers. Fibers provide structural integrity and thermal stability, while fillers enhance wear resistance. Binders often thermostatic resistance like phenolic or epoxy hold the composite together. Friction modifiers like metal powders or lubricants adjust the friction coefficient to meet the specific performance requirements. Next we see the formulation, how these materials has been proportionally added there. A precise formulation is developed to balance the properties of the composite materials. This involves determining the right proportion of fibers, fillers, binders, and modifiers. The formulation must ensure that the final product can withstand high temperatures, pressure, and mechanical stresses during the operation. Computer aided design (CAD) and simulation tools are often used to optimize the formulation for specific application. Mixing. The selected materials are carefully measured and mixed to create a homogeneous blend. This process is critical for ensuring uniform distribution of components, which affects the final product's performance. Mixing can be done using various equipments such as high-speed mixers, planetary mixers, or ball mills, depending on the materials, properties, and desired consistency. Preforming. The mixed material is then preformed into a specific shape using methods like extrusion, calendering, or compression molding. Performing shapes the material into a form and that can be easily handled and processed in subsequent steps. This stage may also involve pure curing to partially harden the binder, making the perform more stable and easier to handle. Molding and curing. The performed material is placed into a mold that shapes it into a final friction lining form. The molding process involves applying the heat and pressure to cure the binder fully, solidifying the composite materials. This step crucial for achieving the desired mechanical properties and ensuring the lining can withstand the operational stresses. Finally comes for the finishing. After curing, the friction lining undergoes the finishing process, including the machining, grinding, and surface treatment. These steps ensure the lining meets the precise dimensional tolerance and surface quality requirements. The lining may also be treated with the coatings to enhance the performance, such as improving its resistance to moisture, reducing the noise during operation. Once again, I want to thank you for watching this video. We'll see you in the next session.